A previous series of videos on trigonometry looked at right angle triangles and the relationship between the angle in a triangle and the ratio of a pair of sides, three ratios, sine, cosine and tangent. For a particular angle, the ratio took on a particular value. The only way to change the value of the ratio was to change the angle. So a series of videos on trig graphs then looked at how the ratio opposite over hypotenuse varied with the angle. As you changed the angle, how did it change the ratio? Also did that for the cosine and the tangent. Used a piece of software for that, which has a right angle triangle here, where the software measures the size of the sides. This is 1 unit long, this is half a unit long, and measures the angle in the triangle. So this is a right angle triangle with 30 degrees in it. At 30 degrees, the sine ratio is 0.5 over 1. So that's the ratio of the lengths. At 30 degrees, this opposite side in red is half the size of the hypotenuse there in black. So this is when the opposite's half the hypotenuse. So sine 30 degrees here is 0.5 over 1, and by making this 1, it means that the value of the ratio is just the same as the length of the line. This red line is of a length sine 30. So sine 30 is a half the length of the line. Plot that point in a graph. There's 30 degrees, 0.5 plotted. That's the coordinates. So along the horizontal, the angle, 30 degrees. Up the side, the value of sine 30 here, 0.5. The only way to change the value of the ratio is to change the angle. If we go to 40 degrees, it's 0.64. So that point could be plotted. If we increase the angle to 50 degrees, the value of the ratio changes. We can plot it. And you can do that as you keep going, plotting more and more values and gradually filling them in. Here at 80 degrees, notice it's 0.98. 0.98. So bear that in mind because it'll come up again. When you get to 90, triangle disappears. The ratio is hypotenuse is 1, opposite is 1, so opposite 1 over hypotenuse 1 is 1. You can't get any higher than that. The graph's at its peak. Sine 90 is 1 and the graph can't go any higher. After that, when we turn to 100 degrees, there's that 0.98 again. It occurred at 80 degrees and it occurs again at 100 degrees. So there in the graph, that's 100 degrees, 0.98. But there was a previous point, I'll go back to it, there was 80 degrees, 0.98. If you kept this going and I gave you 110 degrees, 110 degrees, 0.94. But if I go back to 70 degrees, it's 0.94. In fact, if I keep the triangle going, plotting the different heights, all the values I had before, as we go up, get plotted. All the values on the way up happen again on the way down. In fact, in this diagram, if I get to 150 degrees, I'm back to a half, 0.5. At 150 degrees, this is a 30 degree angle in the triangle, giving opposite side 0.5 over hypotenuse 1. So sine 150 degrees is 0.5. Sine 30 degrees was 0.5. Sine 150 degrees is also 0.5. They're equal. Sine 30 and sine 150 are equal. If I keep the triangle going, there's the 0.5 again. What's happened here is I've turned around 210 degrees, 30 degrees beyond the horizontal. So that's 30 degrees in here. That's what makes the opposite side 0.5. So this is turning around 30 beyond 180. So sine 210, sine 150, sine 30, they're all 0.5. These are related angles, and there's another one coming, which is 330 degrees. When I've turned around 330 degrees, this is a 30-degree angle in the triangle, so sine 30 is 0.5. To get to that 30 degrees in the triangle, I had to turn 330, 30 short of 360. So that's 4 angles that are equal to each other. Sine 330 is 0.5. There's sine 210 is 0.5. And there's sine 150 is 0.5. And the original was sine 30 is 0.5. So these are related angles. 30 degrees, 150 degrees, 210 degrees and 330 degrees are related angles. If you get the sine of these angles, you'll get 0.5. Now, the same would happen with cosine. If you had cosine 30, cosine 150, cosine 210, cosine 330, they would come out with the same answer. Same with tangent. Tangent 30, tangent 150, tangent 210 and tangent 330 would all be the same. So, to illustrate this, another piece of software with triangles. Again, the sides are measured as 3, 4, 5. To get a 3, 4, 5, I need approximately 53 degrees here. Used a 3, 4, 5 because it's whole number sides. It's a Pythagorean triple. It's easy to work with. So the software measures the sides and it measures the angle. And what we've got here is, for this 53 degrees in this triangle, the opposite's 4, the hypotenuse is 5, there's a ratio. Sine 53 is 4/5. Cos 53 is adjacent, 3 over 5. And tangent 53 is the opposite over adjacent, 4 over 3. 4/5, 3/5, 4/3. When that's 53 degrees, 3, 4, 5 triangle, 53 degrees, 4/5, 3/5, 4/3 the ratios. It's 3 along, 4 up, because this is the point 3, 4. If I want to change these ratios, I would change the angle. So when I change the angle here to 63 degrees, different ratios. But this time I don't want different ratios. What I want to do is turn it and find out when these ratios happen again. In fact, if I turn 127 degrees, there's the 4/5, 3/5, 4/3. 4/5, 3/5, 4/3 as we had before, because we've got a 3, 4, 5 triangle when that's 53 degrees. If that's 53 degrees, we're 53 degrees short of 180. That's why that angle of 127 is the same as 53 in the first quadrant. So this quarter in here, we call this the first quadrant, then the second quadrant, then the third quadrant, then the fourth quadrant. So this is a second quadrant, and 127 degrees is the same as having 53 degrees. Sine 127, cos 127, tan 127 were the same as sine 53, cos 53 and tan 53, except 2 of them have gone negative. Because of this -3, we've gone 3 to the left, and that made the adjacent 3, well, the cosine was adjacent over hypotenuse, so it's got a negative in it, and tangent was opposite over adjacent, so it's got a negative in it. So I made the negative ones go red. Sine has stayed positive, 4/5, kept it blue. There's the sine, it's still 4 over 5. Keep turning, and you next get 53 degrees when you've gone 53 degrees beyond 180, giving you 233 degrees. There it is, 180, an extra 53. Sine 233, cos 233, and tan 233 were the same as sine 53, cos 53, and tan 53. It's just, again, 2 of them have gone negative, because it's negative on the adjacent and it's negative on the opposite. That makes the sine and the cosine negative, but the tangent is -4 over -3. Opposite over adjacent, both negative, and negative divided by negatives are positive. Tangent's positive in this quadrant here. And finally, the next 53 degrees is in this fourth quadrant. 53 degrees here gives me the 3, 4, 5. To get there, I had to turn around 307 degrees. 53 degrees short of 360. There it is there. Now sine 307, cos 307, tan 307. Give the same as sine 53, cos 53, tan 53. It's just, again, two of them are negative and only one is positive. So when we went round, everything was positive. The ratios were all positive in the first quadrant. Then only the sine was positive. The other two were negative. Then only the tangent was positive. And then only the cosine was positive. So these are related angles having the same value to the ratio, but sometimes positive, sometimes negative. So when the opposite has gone negative, it made the opposite over hypotenuse negative, and it made the opposite over adjacent negative. The cosine is still positive 3 here over the 5. So cosine's positive. Result. If we look at what we got, everything we got was related to 53 degrees in the first quadrant. If you turn triangle around to get 53, the triangle of 53 degrees in this quadrant, you need 180 minus 53. You turn 127 degrees. If you want to a triangle of 53 degrees in this quadrant, you turn 53 degrees beyond 180. You turn 233 degrees. 180 plus 253 is 233. And if you want to get a 53 degree triangle in here, a 3, 4, 5 as it was, you want to be 53 degrees short of 360. So the angle, 180 minus the angle, 180 plus the angle, 360 minus the angle give 4 related angles. 53, 127, 233 and 307 are the related angles. When you get the sine of each of these angles, they're the same value to the ratio, but the signs can be positive or negative. And here we found the sine was positive. I put an S here for sine's positive. The other two were negative. And here the tangent went positive. That's where it was negative 4 over negative 3. So t means the tangent's positive. And in here the cosine went positive. So this is to remember where things are positive. All are positive here. Only the sine is positive here. Only the tangent's positive here. Only the cosine's positive here. And whether they're not positive or negative. So that's the memory aid. It's this. This is what you memorise, and it's to solve trig equations, which will be in the next video. That really is the thing we're after for today. We'll really use this properly in the next video, but the bit I'm about to show you is, in Scotland, preparation for the higher. So this is for National 5. Preparation for the higher is the bit that's coming up. What's going to happen is, we're going to use this arrangement here, this diagram. This is the thing that has to be memorised. A, 180 minus A, 180 plus A, 360 minus A. These are the 4 related angles. And the ASTCs to remember when things are positive, all positive, only the sine, only the tangent, only the cosine. Some memorise it with CAST, C-A-S-T. You've got to remember you're turning anti-clockwise for the positive direction, and the angle is split into quarters. That's the first quarter. We just call it first quadrant, second quadrant, third quadrant, fourth quadrant. So that's an acute angle A, and this is 180 minus that angle, and so on. So if I put an angle in for it, that was 30, this is 180 minus 30, this is 180 plus 30, this is 360 minus 30. That's giving you that. So 30, 150, 210, 330 rated angles. If you get a trig function, whichever one you choose, if you get a trig function of this 30 degrees, the same trig function of 150, 210 and 330 will come out with the same value, but maybe a different sign. Could be positive or negative. So it's learning how that happens. Let's say you were after sine 30. It's going to be a half. You'll get that in the calculator. You'll get the rest in the calculator, but this is mainly working without a calculator. You would find the other ones would come up here, a half, but and positive, because it's got S, meaning sine's positive. But here, a half, but negative, because it says tangent's positive, and this is a sine 210. And the same here, negative, because it says cosine's positive, and that's a sine 330. So sine 30, sine 150, sine 210, sine 330, they're all a half, but twice it's positive a half, twice it's negative a half. So for all the functions, twice they're positive, twice they're negative in a 360 degree turn. So that's an example using the sine. If you did the same, you did it with the cosine. Cos 30 will come up as root 3 over 2 in the calculator. So they're all root 3 over 2, but could be positive or negative. Cosine comes up negative here because it says sine's positive, not the cosine. Here, again, it's the negative because it says tangent's positive. Here it is positive because it's got the c, cosine's positive. So ASTC is where they're positive. And we did it with the tangent. This tangent 30 is 1 over root 3, so they're all 1 over root 3, these related angles. So you're getting the tangent of these angles, they'll all be the same, but some are positive, some are negative. So here it is. This is negative 1 over root 3 because it tells you only the sine's positive. This is positive 1 over root 3 because here t, tangent's positive. And this is tangent 210. And here, tangent 330 is negative because it's a sine. It's a cosine, I should say. It's a cosine, it's positive in here. So, that's the related angles. It's remembered as A, 180 minus A, 180 plus A, and 360 minus A. And the ASTC here is when the functions are positive. All, only the sine, only the tangent, only the cosine. That's the thing we need for solving trig equations. At the moment, we're going to take angles that are over 90 degrees and turn them into acute angles. It consists of this. When you've got 100 degrees, you're turning 100 degrees right into the second quadrant here. So this is turning 100 degrees. You're 80 degrees short of 180. In other words, A is 80 here. It's 180 minus 80 that gives you 100. That's the acute angle then. The acute angle is 80. So sine 100 is the same as sine 80. And because it says S here, sine's positive, it's positive sine 80. And that's that finished. 120 degrees, turn around 120 degrees, you're 60 short of 180. A is 60. Cos 120 is the same as cos 60. But it says the sine's positive. And in here, your cosine then is negative because you're in this quadrant. Tan 145, turn around 145 degrees, you're 35 degrees short of 180. A is 35. Tan 145 is the same as tan 35. You're in here. It's a tangent of 145. Well, this tells you the sine's positive, not the tangent. So here it is. If you turn round beyond 180, you're into the third quadrant in here, the 180 plus A bit. If you've got cos 200, if you get cos 200, you've turned 20 degrees beyond 180. So A is 20. Cos 200 is the same as cos 20. Tells you the tangent's positive, the cosine's negative. Tangent 190, turn around 190. A is 10. 180 plus 10 makes 190 up. So tan 190 is the same as tan 10. Tangent's positive here, so it's positive tan 10. And in this quadrant, 240 takes you right around 60 beyond 180. 180 plus 60. So sine 240 is the same as sine 60, but tangent's positive, not the sine, so it's negative sine 60. Finally, this fourth quadrant, turning around beyond 270, so 300 degrees here, turn right round, it's 60 short of 360. 360 minus 60 makes your 300, so A is 60. Cos 300 is the same as cos 60, and because it tells you cosine is positive, it's positive cos 60. You don't need to put in the positive signs, it's just to indicate how this is working. 335 degree turn right round 335 degrees, you're 25 degrees short of 360. 360 minus 25 makes 335. So sine 335 is the same as sine 25, and because it tells you the cosine only is positive, and here the sine's a negative answer. And finally, tan 310, turn around 310 degrees, you're 50 degrees short of 360, that's 50 for A. Tan 310, same as tan 50, because cosine only is positive, this is a negative tan 50. So these are equivalent angles. You're basically using these four things to decide about the angles, the turning. At that point, the function doesn't matter. You need to know the function to tell whether it's negative or positive. That's all with the ASTC. So the bit in blue, the ASTC, is it negative or positive? To turn 100 degrees into 80 degrees, you're thinking of what is A? What's this acute angle being? So A is an acute angle between 0 and 90. You're trying to get that angle. The worksheet on that, doing exactly what I just showed you there. If you click the link in the description, it gives you access to the worksheet with the answers. That's the first half of the worksheet. The second half uses these triangles. They're very useful for higher because this is a routine at higher in Scotland. So what you have here is a 30-degree triangle. Sine 30 was a half, opposite 1, hypotenuse 2. Apply Pythagoras, adjacent here. A squared equals 2 squared minus 1 squared, which is 3. A squared is 3, A is root 3. So you can work out the missing side by root 3. So if you can remember sine 30 is a half, you can sketch the triangle with 30 degrees and 1 over 2. Work that out as root 3. You know that's 60 to make up the triangle. And therefore you can get values for sine, cos and tan of 30 degrees and 60 degrees. They're called exact values because you're not having a decimal written down and rounding things off. This is non-calculator work. So if you want sine 30, you say opposite 1 over hypotenuse. Cosine 30, adjacent root 3 over hypotenuse. Tangent 30, opposite 1 over adjacent root 3. Up the top is 60 degrees. If you want sine 60, it's opposite root 3 over hypotenuse 2. There it is. If you want cos 60, it's adjacent 1 over hypotenuse 2. If you want tan 60, it's opposite root 3 over adjacent 1. And that therefore comes out as root 3. A second triangle we also memorise, it's like half a square. Think of a square 1 by 1, and you half it at 45 degrees here. Since that's 1 and that's 1 and it's right angle, Pythagoras would say h squared equals 1 squared plus 1 squared. H squared is 2h, the hypotenuse is root 2. Sine 45, 1 over root 2. Cosine 45, 1 over root 2. Tangent 45, opposite 1 over adjacent 1. So there they were, 1 over root 2 for the sine and the cosine, tan 45 being 1 over 1, you would just write that as 1. So these are exact values. And now you take that and what we did for the previous half of the sheet and you would combine it. So if you were asked to get the exact value of sine 240, you think I turn 240 degrees. I'm in here where it says 180 plus A. This must be 180 plus 60. So 180 plus 60, that means sine 240 is the same as sine 60. But is it positive or negative? Well, it's negative because it's in this third quadrant where it says T, tangent's positive. So it's negative sine 60. Exact value is sine 60. If you got to the triangle, sine is opposite root 3 over hypotenuse 2. And that becomes negative root 3 over 2. This is the angle you're asked to get the exact value of. 2 stages to it. This stage and finally the exact value. The second half of the worksheet, you do these 2 things. So don't just write the answer, you write this line and then that line. So if you get access to the worksheet using the link in the description, it'll have the answers to these. But this is really to get ready for the next video, which is solving trig equations. You can get that worksheet, as I said, there it is there, and it'll have the answers. And also, you can get a set of notes which cover all the trig equations videos. Hope you find the video useful.